Asia-Pacific Forum on Green and Low Carbon Development, promoting a peak in the carbon emissions of the building sector parallel session now officially starts. I'm the moderator, the Vice Chairman of Broad Group, Mr. Ding Yuangang. Honorable Academician Qiu Baoxin, honorable guests, the online and offline participants, good afternoon. For the building sector, as you know, is one of the largest energy consumption sectors. Some people say 50%. As the urbanization trend is going on, and the global building sector has been increasing. So the dual carbon strategy is something that we are becoming aware of, and this is a must for a sustainable development in the future. This afternoon, we have invited leaders, experts, industry elites, and green companies. They will be discussing the carbon emissions and carbon peaking path for the building sector. We hope that this will contribute to the future carbon emissions and energy saving, and there can be consensus reached. Some people say that the emission savings of building is very important for developing sustainable energy. Some people say that carbon emissions of the building sector is the carbon emissions at the demand side. It will reduce the energy consumption of the building sector for the whole life cycle. So we will be hearing the insights from the experts and the guests. And next, let's give the floor to Mr. Qiu Baoxin, the academician of IEAS, former Vice Minister of MOHOT, and the Council of the State Council Office. His topic is the carbon reduction pathway for 3 areas of city commonality. Welcome, Mr. Qiu Baoxin.
I think the sound, the voice is not coming through. Minister Qiu is going to give his presentation online. I think there's a problem with the signal here. Can you hear me? I think the volume is too low. It's not very clear. I think the IEA side needs to move out of the system, and I think we can hear you now. I can't show you my slides, and I think the IEA needs to exit the slide share. The IEA. I think the IEA, you need to remove your slide share now. so that I can share my slides. Now your slides is actually occupying the system.
先不要把 PPT 共享太多。它这个 PPT 还没退出，我这个 PPT 打开的。
IEA needs to exit the slide share. Yes, and then I can share my slides with you.
第一阶。先退出。
Okay. Okay, we can see your slides now. So today I want to talk to you about the carbon reduction paths that are commonly shared by the cities in 3 areas. Cities play a dominant role in carbon neutrality. So actually here, I think most important part is safety. And secondly, it's about the cost of technology needs to go down. And thirdly, reliability of the technology needs to be high. And fourthly, compatibility of the gray and green systems. And number 5 would be import substitution. The good news is that in China, the cost for renewable energies, especially PV, have shown a significant reduction in the past 10 years. And also the cost for wind power has been declining as well. And in the next few years, I think this will have a major role to play in helping the cities to achieve carbon neutrality. Because cities actually contributed the most to the greenhouse gas emissions from human activities, up to 75%. And actually in China, the cities will include the built areas and also some parts of the rural areas and the wildlands. So it is actually feasible for us to plan renewable energies and some carbon sinks. And as we can see, there's a fierce competition between hundreds of Chinese cities. And now the competition for GDP between cities needs to be shifted to a competition between cities for a carbon reduction. And the carbon neutrality is something that every city wants to achieve at an earlier stage. And this dual carbon strategy focusing on cities takes a bottom-up approach. It can be viewed as a more deeply embedded system to achieve carbon neutrality, which is complementary with our top-level design and the top-down approach to enforce mandatory emission cuts in carbon-intensive industries. And here we have some different modules for the carbon neutrality of cities, industrial and waste disposal, transportation, buildings, and also carbon sink, as well as the rural and agriculture. I think for all the cities, they will share 3 common areas in spite of the possible difficulties in these 5 areas. So this slide actually shows the different technologies that have been adopted and also the policies that have been exercised. And as we can see, the x-axis is about the uncertainties, and the y-axis is about returns and benefits. And as we can see, the mandatory measures like power cuts are highly uncertain and also with very low returns and benefits. And also the carbon capture and storage measures with the power plants as the dominant player is also highly unstable. But if we can use more renewable energies, the benefits will be high in the long run with higher stability. And most of these new technologies are still under development, including the biotic sequestration. And now, hydrogen is playing an increasing role. But actually, if the hydrogen comes from renewable energy, which means that it's green hydrogen, then the carbon emission will be quite small compared with the gray oxygen that comes from the fossil fuel used in transportation. And also, as we can see, the different sources for the same type of fuel would also produce different amount of carbon emission. And methane actually constitutes a very good example of that. And if we look at urban transportation, if we look at their carbon emissions and also the footprints as well as the PM 2.5 discharge, if we compare all those indicators, the top-range EV and dual occupancy cars, they're also quite high in terms of carbon emission, and also motorcycle ranks quite high, both in terms of carbon emission as well as PM 2.5. And that's why we are pleased to see the ban of motorcycles in China. If we look at the carbon emission of EV, if it uses green technology, it's actually quite low. And if we use the fossil fuel, actually the carbon emission can still be kept at a low level. And that is why we are seeing the introduction of the banning for the sales of fossil fuel vehicles in all the countries. And the third area is building. The buildings actually contributed over 48% of the total carbon emission in China. But internationally, that number only contributes 30% of the total consumption from the society. But in China, that percentage is a lot higher. That is because a large percent of the buildings in other areas of the world are made of wood, timber. However, in China, most buildings are made of reinforced steel and concrete. Wood is seldom used in construction of buildings in China. So the total carbon emission from the buildings in China is around 10% than the average level in the world. And as we can see, the public buildings contribute a lot to the carbon emission. For every square meter of the building, about 36 kilograms of CO2 is produced for heating throughout the year. And central heating in North China also contributes significantly. And if the public buildings' carbon emission can be reduced to the level of Japan, then we can successfully reduce a large amount of carbon emission. However, we must notice that if we adopt a pay-as-you-go model for heating in North China instead of a centralized heating, then the energy consumption can be successfully reduced by 1/3. That equals the total energy consumption of Poland. And also, when we talk about green buildings, we need to look at the different features that it should have. For example, whether the green building will actually change and adapt to the seasons. And to see if we can reduce carbon and save water, materials, and land throughout its life cycle. And actually, the provision of heat as well as the supply of cooling can be adapted according to the change of season, and then the energy flow can also adapt with the change of season. So we see a huge potential for the development of green buildings. It can accommodate lots of technologies, and it can change automatically its energy adjustment system according to the season. That should be a major characteristics for green buildings. And as you can see, in China, we can actually try to popularize buildings like this in North Germany. Probably in North China, it will be more useful. And in China, the PV cost is very low now, as low as the construction materials, actually. And different materials can be used for the rooftop and also for the building shells, the facades. And more importantly, in the neighborhood or in the communities within the city, they can actually form a micro-energy community using the wind power on the rooftop and also bioenergy, solar energy, and also the EVs. The EVs can be used as a unit which you can charge during the valley period and discharge during the peak. Actually, by 2040, there will be around 200 million to 300 million EVs in China, which means they can actually store half of the electricity from the power grid. So these EVs, as I said, like in 11 p.m. or between 11 p.m. to the next day and in 8 a.m. they can store power, and then in daytime they can discharge power. So the whole community can be seen as a power generating and storage unit. And this example shows you a case of aquaponics in Holland. It can actually produce around 40 tons of vegetables and 20 tons of fish every year. And most of the vegetables are converted into fish feed, and the fish excrement becomes the fertilizer for the vegetables. How come the production is so great? Because 24 hours of lighting was used to speed up the growth of vegetables, and these vegetables were actually growing for 24 hours. And by this means, the supply of power for the vegetables can be ensured, and also the energy consumption at the same time can still be reduced. And this is the Shanghai South Railway Station, designed by a German architect. I think this kind of architecture is quite good in Germany, but not as good in Shanghai. Because in Shanghai, because of hot summer, this kind of a building would consume more energy than the other types of buildings. If in Guangzhou, then the energy consumption will be even higher. And also another problem that we were seeing is the over-suburbanization of the city development, as well as the building of super high-rises and central air conditioning system. These are some of the so-called negative list for reducing carbon emissions. And number 4, disposal of waste and municipal utility. I think the key is to achieve a balance between production, consumption, and degradation. Degradation usually required large energy consumption. And therefore, we need to see what improvements can be made in the circulation of waste, of water, and of materials. Actually, after over 300 years of predatory exploitation, over 80% of the mineral resources that can be industrially utilized have been transformed from underground to underground, and they are actually around us in the form of garbage. And our buildings use a lot of steel and water and construction materials, and if they can be converted into cotton steel or stainless steel, then after decades, these steel can still be recycled and reused 100%. So if we can recycle and reuse this kind of material, then the cost and also energy can be significantly reduced. 100% recyclable and reusable materials for buildings. Such kind of buildings will also be easy to maintain, and they can be highly corrosion resistant. In terms of wastewater treatment, usually we will build a water treatment plant, and also with, usually we will transfer the water from a long distance away. But it is preferable to use this container size, small scale, in situ water treatment facility. And there are 2 switches. The first one is the EGB, and the water discharged can actually be used for watering the flowers and vegetables, because this part would be the reclaimed water. So most of this reclaimed water, if we can save them and reuse them, then half of the water can be successfully saved. Speaking of waste disposal, usually the water for shower, for bath, will be collected and used to flush the toilet. If in Beijing, Tianjin, and Hebei areas, if all these residential areas can use such kind of reclaimed water integration system, then the amount of water then that is expected to be saved can be huge as well. And now about the low disturbance technology for passive rainwater treatment. Bioretention basins and permeable pavement can be used. And now here I'm showing you how much effect can be produced by growing trees in the same place using the infrared camera and also the regular camera. As you can see, those areas with the trees, actually the temperature will be lower. And one tree can absorb a ton of water, and 99.5% will use for evaporation. And evaporation can reduce temperature. So probably we should consider a different way of layout when we are trying to make the city greener. Instead of building a large area of green land, we should try to use a more dispersed green lands and green layouts. And a very typical example would be the green buildings. Using these green buildings, the green rate can be as high as 100%. And this is a balcony in a green building where you can grow flowers and vegetables. And now the Zhejiang provincial government has issued a policy saying that it is allowed for the residents to grow vegetables and flowers on their balconies. And probably in the future will be encouraged. So such kind of buildings with trees growing on them and in them, and also with different plants surrounding them, and equipped with a water reclaim system, as well as a waste disposal system, will greatly reduce carbon emission. And by using this technology, I think by 2025, the per capita carbon emission can reach its peak, probably. And then the second stage, the power system can reach a carbon neutrality with a different set of technology, of course. And the third phase, transportation and the other industries will also attain carbon neutrality. Thank you.
Thank you very much, Mr. Qiu Baoxing. Minister Qiu's presentation has both tests and pictures, and he talked about urban planning, building energy saving, and use of sustainable energy, waste disposal, circulate economy, and the sponge city, and also afforestation and greening of the gardens. And in terms of low carbon city and low carbon life, he has pointed us with directions. There are some technical hiccups. I hope that we will have offline speech. So I hope that the staff can adjust the video because we have the online and offline speech, and 4 speakers will be speaking online via video link. So the audio effect and the power presentation sharing are very important. So after the presentation, we will have Q&A, and we may ask questions to the online guests, or we will also have offline Q&A. So we hope that our technical staff can adjust the system, especially ensure the quality of the speech and quality of the sound. And you all have the bio of the guests on the menu of the conference. I will not dwell on the bio. I will only talk about the major titles of the guests and where they're coming from. Next, let's give the floor to Mr. Xu Ling, the chairman of the U.S.-China Green Fund, the former Director General of Department of Development Planning of NDRC. And his topic is promoting green and low-carbon transformation of buildings in urban and rural areas driven by carbon neutrality. Welcome. Thank you. I'd like to thank Broad Group for inviting me to attend today's session. Well, I'm not an expert in the building sector. I'm not an expert for the climate change. So I'm engaged in investment, especially green investment. So green and the low carbon sector is a very important sector for our investment. In the course of investment, we need to learn and we need to understand the green and the low carbon transformation and the opportunities and challenges brought by them. So I will share my insights around the theme of today. I only have 10 minutes, so I will talk about 2 points regarding the energy saving building and the building energy saving. So after the dual carbon target has been proposed, everybody has been paying great attention to that. For China, achieving these dual carbon targets, as put by President Xi Jinping, is a deep change and transformation in all aspects. And for China's economic development, it means a green and low carbon transformation of the economy. So it must be done in the course of 40 years. So the path and the process will be much shorter compared with the developed countries. So from carbon peaking to carbon neutrality, most developed countries have spent 50 or 6 or even 70 or 80 years. And for China, from carbon peaking to carbon neutrality, we only have 30 years. So we're under great pressure and challenges compared to them. But we do not need to feel pessimistic. In my view, from carbon peaking to carbon neutrality, we face the technology support, and actually the technological support is much better than those faced by the developed countries. And the low-carbon technological progress has seen great advancement in the past 20 or 30 years. And Mr. Qiu has mentioned that as well. For example, PV power generation. In the past 10 years, the cost per kWh reduced by 80 or 90%. So that means to achieve the low-carbon and green transition, we have much more reliable technologies. The carbon emission reductions for China is in essence an energy issue. It means an energy transformation. Why? Because currently, for the 10 billion tons of CO2 emissions, coal contributed about 80%. Oil, 10%. Well, oil, 15%. Natural gas, 5%. So for China to reduce emissions, It means we need to replace the fossil fuel, and the focus is the replacement of coal. Replacing coal is not an easy task for China because we are relying on coal consumption in the past because of our natural resources endowment. In the next 40 years, coal will continue to play a major role. And the coal consumption reduction or replacement of coal will be gradual, and it will take dozens of years. Even if we reach carbon peak, experts think that in the future the coal consumption will still maintain at a range of 1.5 billion tons. Currently, the coal consumption is about 5 billion tons, so there is a huge deduction that has to be made. And we need to look at different sectors and the contribution of them for the carbon emissions. Today, we're focusing on building sector. Mr. Chiu has explained one graph. During the course of construction, the CO2 emissions is about 4.9 billion tons. So it's like 50% of the total emissions in 2020. So how should we decarbonize the building sector? This is something that the building sector has to contribute to the climate change. I think, in essence, there are two things that need to be done. The first one is the energy saving of the existing buildings. Why is that important? I don't know how much space currently for the existing buildings. Well, if you look at the energy-saving building, actually the percentage is not very high. In Beijing, in the cities, we think that many of the buildings, including our own residential buildings, are not energy-saving buildings. When making investment, when we are visiting cities or energy-saving service companies, we found that their investment for energy-saving building retrofit will contribute 20% or more of energy savings, and the investment payback period is about 4 years. So the retrofit of the existing building is very important, and there is a big room and potential, and it is also worth investment. And there can be many ways or approach for retrofit of the existing building. For example, the smart energy supply system can be used, and through the smart energy management system, the energy consumption of a building can be much more efficient. There is another new way which is becoming more and more popular. So that is the multi-energy complementarity, which is an integrated energy supply system. And Mr. Chiu also touched upon this concept. For example, in a residential compound or industrial park or in a building, and through the distributed PV or thermal heat, they can actually use those different sources of energy. And those energy can complement each other. And also there should be a good energy storage system. So it can replace the traditional fossil fuel. And second, through increasing energy efficiency, it can actually save energy. This kind of approach has been adopted in more and more cities, industrial parks, and big buildings, and the effects have been very good. Considering our current energy efficiency, especially compared to Japan and Germany, we still have 30% to 40% gap. So in terms of emission reduction and carbon peaking, we still have a big space to tap. If we want to achieve 20 to 30% of energy saving, that means we can reduce the same percentage of coal consumption. So this is something that's worth trying and working towards for carbon peaking. The other one is to build new energy-saving buildings. So we need to make sure that the new buildings must be energy-saving. And this is not something we have been doing very well. And the new buildings have to apply the strict building code, and many of them can't meet the requirements of building code. And we need to use the concept of carbon neutrality to build the existing industrial parks or urban or rural communities. And we need to use the concept of carbon neutrality to design and plan the buildings. This is something that has been done in Europe and also in many developed countries. And second, we need to use more advanced energy-saving building materials. In order to promote energy saving, we find there are energy-saving glass, insulated materials, and many other energy-saving materials. And for example, Broad Group, Mr. Zhang Rui has invented the stainless steel slab, and which is also energy-saving material. So we have to use more advanced energy-saving material so that the buildings will achieve high energy efficiency. In terms of design, plan, and construction, we face one big issue, that is the cost. So if we want to apply high standards and good materials in the buildings, you may find that whether it's for individual buildings or residential compound, the construction cost will increase. People think that this is not economical, and we need to adopt a more long-term view. Personally, we need to look at the life cycle cost of the building. And in China, many buildings have a short lifespan. That will bring many problems. So the building may sustain for 30 or 50 or 70 years, and after that they have to be demolished, and there would be a lot of building waste, and you have to rebuild the buildings. And in constructing the buildings and making the materials, it will also emit carbon. So the building lifespan and quality should be something that is balanced with cost. Like the Broad Group, the stainless steel zinc-coated slab, compared with the current material, the cost may be 30 or 40% higher. But in terms of lifespan, because it's all steel, actually the stainless steel is actually corrosion resistant, so the lifespan can be 500 or 600 years. So if you look at the cost in this way, the cost is not that high. And if you apply the concept of carbon neutrality, then this building is actually quite useful and is something that's worth a bit of more money. So how should we incentivize the constructors to use those materials? This is something that the government has to think about. So for those new building materials, it will bring environmental benefits and also emission reduction benefits. So how can it be accounted for? in terms of calculating the revenue for the building. This is something that we need to think about when building the ecosystem or carbon neutrality and designing the incentive policies. So without doing this, then the constructors or the house owners, they will not have the incentive to buy a more expensive material that is more energy efficient. So this is something that we need to think about in the future when we promote low carbon and green buildings. And this is all from me. Thank you.
Thank
you, Mr. Xu, for your very informative speech. So we have low carbon products, low carbon finance, low carbon technology, low carbon policies, etc. So this afternoon, we are actually participating in a very, very important session. As Mr. Chiu showed in his PPT, the buildings contribute to nearly or even over 50% of the total energy consumption from the society during its life cycle. Just now, Mr. Xu talked about green investment and green finance. And then we also have more presenters who are going to talk about green finance later. And the next presenter will talk about green products and technology. Mr. Peng Ji, Vice President of Broad Group. The topic of his presentation is Development Strategy and Implementation for Carbon Peak and Neutrality Targets of Broad Group. Good afternoon. So today I'm going to report to you the dual carbon strategy of Broad Group and how we're going to implement it. So we actually invited Mr. Chiu, who used to be the Minister of Moherd, and he actually talked about the top-level design for implementing this strategy. We also have the pleasure to invite Mr. Xu, whose local hometown is in Hunan. And Mr. Xu also used to work in the development and physical policy department of NDRC. And he also mentioned the policies, and now he is actually expressing his ideas from the perspective as an investor now. So I am going to focus on the technologies, green technologies used in the buildings and also some of the business models. So a little bit of a self-introduction. I've been working in Broad Group for 20 years, focusing on energy-saving technology in the central AC and other facilities. So first of all, about our green development, and secondly, how can Broad Group reach a carbon peak, and then also some of our products to implement the dual carbon strategy. This year marks the 5th anniversary for the opening of the Asia-Pacific Forum on Green and Low Carbon Development. As I can remember, Hunan province and the governor of Hunan province has invited his old classmates, and they paid a visit to Broad Group. And also it was during that year the Asian Development Bank and also the Hunan province decided to inaugurate the first Asia-Pacific Forum on Green and Low-Carbon Development. And the Hunan provincial government has also been supporting the development of Broad Group. And we've also received a high recognition from the government for our efforts in reducing carbon emission. And now we deal with AC, central AC, energy, clean air, and also sustainable buildings. And now we hold shares of over 30 companies in the world, and we have a presence in over 80 countries and regions globally. In the past 3 decades, we've been awarded lots of honors, and we value those honors related to green development very much. For example, in 2011, we've been awarded as the guardians for the Earth, and also we've been participating a lot of international events, especially our chairman. We go to lots of events on green development around the world. And our green development history started back in 1992, our first direct fire non-electric central air conditioner, and to the air conditioner fueled by exhaust gas, and also the green buildings, sustainable buildings. All our products will focus on bringing a better environment for the humankind. Now, the dual carbon strategy has been receiving more and more attention in the society. In Yantai, Zhenjiang, and Shenzhen, multiple Chinese cities, there have been events on carbon neutrality. People are talking about how can we reach a peak in carbon emissions and also attain carbon neutrality. In Broad Group's perspective, we actually have over 30 years of experience in making our products greener. And I believe we can have a lot to contribute to the green buildings, low-carbon buildings, and also for the development of a cyclic economy. Just now, Mr. Xu mentioned the renovation and retrofit of the existing buildings in terms of their energy consumption. Actually, we've started this part of work early on. Still, I think there is still a long way to go in this regard, because the ROI, the payback period, turns to be quite high as 5 to 8 years. And Broad Group actually now has probably the first community in China that has fully renovated its buildings for energy-saving renovation. And 80% of energy consumption can be successfully reduced in this community. So with our external wall thick insulation, 3-pane plastic frame windows, window shades, and heat recovery fresh air system, plus our magnetic AC and single heat direct fire machines, the carbon reduction targets can be successfully achieved. And with the heat insulation on the buildings and also the energy-saving ACs, those would be our key products. And at the same time, we also provide energy-saving services for our customers. For example, we've seen the investment of 60 million RMB in the Hunan People's Hospital. and they don't have to purchase any extra equipments, and no extra OPEX will be inflicted. And actually, in the first or the second year after the innovation, the customer can successfully reach a carbon peak. That would be our objective for them. So we do have expertise in system design, in manufacturing, and also project construction, as well as management operation, and also in investment and financing. Customers can adopt this fully financing model or also a partial investment model. And here are some of our EMC cases. The EMC projects run by us reached 70 million square meters. And in the Nanjing Hexi community, as you can see in the middle, about 2 million square meters of the surrounding areas have been served by us. Using the residue heat from the power plants. And also the Nanjing project covers another 2 million square meters. And our renovation technology for the existing buildings can be best exemplified by these products. A very good case for green building. The buildings contribute 50%, around 50% of the total energy consumption from the society. And according to Mr. Qiu, in 2018, these buildings actually contribute to a very large part, 50% of the total energy consumption. But in terms of the building operation will contribute about 2.2 billion tons of carbon. So then, as we can see, the large part of energy consumption will occur during the construction process of the buildings. And this is our case of Holland. It is a literal Chinese translation of living buildings. It uses these super lightweight and super strong stainless steel B-core slab. Also developed by Broad. And all these slab will be made by stainless steel, and also it's highly heat insulated. And this stainless steel have a very, very long lifespan, almost 1,000 years, which is 100% recyclable. It also uses the external window shading and internal heat insulation, and also the three-pane windows, as well as the rockwood insulation walls. And the cost is low based on our bulk chip mechanism, as well as our mass production mechanism. So, and our efficiency for putting up the building is actually 20 times higher than the on-site construction. At the same time, because of a high insulation, the operation cost of the building can be reduced by 80 to 90%. This is the internal structure of the slab. Here's the rockwood, and these are the three-pane windows. This 22 cm rockwood thermal insulation equals to the simulation effect of a 2-meter thick concrete. And these would be the construction, how the buildings is putting up on site. And now I would like to show you a 3-minute video.
09年开始研发，作为一家这个没有上市。
We started to develop these products in 2009, and we've invested over 8 billion yuan into its R&D. And back then, we were not a listed company.
大家可以看看我们这个
As you can see, inside this slab, there are two thin stainless steel slabs, and within these two slabs, we have the extremely thin array of the tubes, 1,100 degrees centigrade of hot air copper bracing technology to install. The lifespan of a product is extremely high, as I said before. And just now, Mr. Chiu showed you some technologies to reduce carbon. I think there are three technologies in the building sector that Broad Group can contribute. The first one is PV and wind power. Our buildings will use renewable energies, and that's why. And secondly, we can actually reduce the energy consumption of buildings by making more energy effective ACs. And also, we can achieve something that is proposed by Mr. Chiu, and that is to extend dramatically the lifespan of buildings. Thank you very much.
Thank
you very much, Mr. Peng. So Broad has been established for 33 years. So it marks 33 years of environmental protection. Starting from day one, they have been following the concept of energy saving and emission reductions. From our R&D, from our actions must be linked with environmental protection, low carbon. So June the 5th is the day where we found our company. It's also a World Environment Day, so the 2 days coincide with each other. The Hunan government and CPC committee and the Department of Environment also have been very forward-looking. The dual carbon strategy of President Xi Jinping has a history of 2 years, but for our government, so they have started to work with ADB 5 years ago in hosting the Asia Pacific Forum on Green and Low Carbon Development. So green, low carbon, and environmental protection has been classified as a major theme for the conference 5 years ago, and we have renewed the agreement this morning. So the government has been attached great importance to the low carbon and environmental protection, and we are leading the other companies and individuals and civil groups to practice green and low carbon style. So our session is focusing on the peak in the carbon emissions of the building sector, and we have 220,000 people watching this session online. So this is a quite influential session, and we are very fortunate that we have so many people that has been following the green and low carbon topic. Next, we're going to give the floor to Madame Melanie Slade, the Senior Program Manager of Energy Efficiency in Emerging Economies of the IEA. She will be delivering the speech online. The floor is yours, Madame Melanie Slade. Sorry, we cannot hear the sound. Can the technical staff please make adjustments? Please wait a few moments. So let me introduce the Melanie. She is a really competent speaker, and she is the Senior Program Manager of the Energy Efficiency Emerging Economies of IEA. Well, around the world, she has 30 years of experience in designing and implementing energy efficiency policies. And she used to work in the UK for the industry's energy saving. And since 1990, she has been working in China. And in 2007, Madame Melanie became the chair of the energy saving program for New Zealand, and then she moved to IEA for managing the emerging economies' energy efficiency. And she also worked with Brazil and South Africa and Thailand policymakers. And she has made a lot of energy saving policies. So now let's hear from Madame Melanie Slade.
Melanie.
Okay.
Is it okay now? Okay.
梅兰妮女士，
So you have muted your microphone. Is that the case? Please switch on your microphone. Well, is the microphone on? But we cannot hear the sound on site. It seems that the sound is too small. Is it possible to increase the volume of the sound? We cannot hear any sound on site at the moment.
"什么问题？
What are the issues? We cannot hear the sound. I think there are some problems with the microphone of the speaker. I think the microphone of the speaker has some issues. So can you please communicate with her in English? Thank you.
PPT 倒很精彩啊。
She has made a really good presentation and PowerPoint slide.
我发现这一次会议关注
It seems that many people have been following our event. 230,000 have been watching our session online. So can our technical staff please ensure the sound is of good quality? Sorry, can we invite the next speaker to speak first? So let me communicate with Madame Melanie.
按照那个组委会的建议，
according to the suggestion of the organizing committee, we will ask the next speaker to speak first. That is the Mr. Alfredo Bano Liu, the Senior Energy Specialist of ADB. So let me introduce this speaker. So he is the Senior Energy Specialist of ADB, and he has been working in the Independent Evaluation Department. And also, he has 15 years of experience working on energy infrastructure sectors in Europe and Asia. And you can see his bio in the forum handbook. Now let's give the floor to Mr. Alfredo Bano Liu, the Senior Energy Specialist from ADB. Thank you.
Hi, good afternoon. Please confirm if you can hear me and whether my presentation is up. Is it okay? Yes? Okay.
非常清楚。
Right, excellent. So
We can hear you very clearly.
technical issues, it in life always happens. So surely Melanie will be able to connect in a few minutes. Anyway, I have prepared a short presentation about what are the benefits of centralized heating and cooling solutions for buildings, as this is the topic of this session. My presentation
Alfredo,
is,
sorry.
I keep it quite,
Could you share your screen, please?
yes, I'm sharing. Can you see now?
No,
Is
we
it okay,
don't
the
see it yet.
presentation?
看不到幻灯片。
We can't see your slides. The audience cannot see your slides. They can't see your slides.
I cannot hear any confirmation, so I assume it.
还
All
看
right,
不到
so
幻。
I will be speaking about, again, centralized heating and cooling solutions. This is
看不到幻灯片。
We can't see your slides. We can't see your slides. The audience cannot see your slides.
So I want to touch upon very quickly on the situation that we're living right now. As you can see from the graph, in the last 30 years,
还是看不到幻灯片。
we have moved from
能听到我的声音吗？
Still no slides coming.
看不到幻灯片。
No slides. No slides. Still no slides.
Load the slides, please.
阿尔弗雷德先生，我们看不见，会场看不到你的幻灯片。
let me see if you can see now.
哦，可以了，可以了。
Yes.
All right. I think I was seeing it only myself. Okay. Can you see now the whole screen?
Please
Helen? Yes?
take
Okay.
off the center.
All right, sorry again for these little hiccups. So let's move on already to the first slide. As you can see, there's been, in the last 30 years, a significant change in where the population is being located. 30 years ago, only 750 million people were living in cities, whereas nowadays we have 2.2 billion. This is around 30% of the world's population.
Sorry, Alfredo.
Yeah.
The slides are on center view. Can you convert it to slideshow?
Yeah, I can. Let me see if you can see.
Yes, that
Yes.
works. Thank you.
Finally. Okay. Let's continue, otherwise we run out of time. So, as you can see, there is a massive migration from rural areas to urban areas. We have, particularly in Asia, as you can see on the graph on the left, on the right, you see that the graphs show a higher growth in East and Northeast Asia, which that's essentially China. Also some growth in Southeast Asia and that part of the world. So we see that there are 21 out of 32 cities with more than 10 million people, the so-called mega cities in Asia. which is, it speaks about where the concentration is happening. And there are some estimations from the UN that around 68% of the world population will be living in cities by 2050, which has a significant impact on how we plan our cities from now on and how are we able to handle urban energy. So what is the issue? If we have so many people living in cities, how are we using that energy? The IEA estimated in 2013 that 64% of the global primary energy is consumed in cities. And that has an associated emission source of around 70% of all emissions on the planet. This is a massive impact. The more we move to cities, the bigger the cities are, the more emissions are associated to them. And that's where we have to start working ahead in order to reduce that carbon and energy intensity. From that energy consumed in cities, around 1/3 are consumed by buildings. In buildings, I mean residential and commercial buildings. And from what we see in this graph, another source from the IEA, in 2020, from 2010 to estimated 2040, we see a massive growth of the use of electricity as a source of energy for buildings. We can see a decrease in coal and oil use. That's related to how we heat up those buildings, increasing natural gas, again related to both carbon policies and the price. And then we are seeing as well some decrease in bioenergy. Essentially, this bioenergy are related to buildings where people are using biomass, like firewood. And the more people move to cities, the less amount of bioenergy they will be using. And also we see some growth in the use of renewable energies, like, for example, solar thermal for water heating, solar PV, and all these aspects. Now, where can we save energy and where can we reduce emissions in this in urban energy, in the urban energy space? This graph from the Stockholm Environment Institute shows us that most of the savings, as you can see here, will happen in buildings. 61% of all the energy we may save will come from the space from the building space realm. That has important implications on how we talk about buildings and how we build them for the future. As it was mentioned by previous speakers, they have a life of perhaps over 100 years. If we're not able to design them well now, we'll be able to suffer for inefficiencies for a long time. So how we're using energy in our buildings? Obviously, it depends on the climate, it depends on the part of the world we're living. This is from the European Union, and we can see that around 64% of all the energy we use in buildings goes only for space heating. As you can understand, the European Union is in a temperate weather climate, so you see that we have very mild summers, and relatively colder winters. So most of the energy will go to space heating and water heating. This is about 80% of all energy goes to heating up water, essentially. If we move to other areas, like for example in the US, the distribution is a bit more balanced because they have different types of climate. In the US, 30% of energy in households is used for heating, around 17% for cooling, and 14% for water heating. Around 1/3 of the whole energy uses are for thermal uses, not electrical uses as appliances, lighting, and other things. If we move to the country in a warmer place, in the equator, like Singapore, we can see that obviously there is no heating for space heating, but we have some water heating, 21%. We have around 36% for air conditioning and 2% for fans, which combined it's about 40% for cooling spaces. Now, the IEA, again, did great work in a previous report on the future of cooling. And there are some chilling predictions on where we're going as of now in terms of how we're going to increase cooling in a large part of the world that is currently not accessing it, meaning the developing world, in particular India and some parts of China. As you can see in this graph, as of now, we have around air conditioning stock of around 1,500, but that is expected to almost quadruple by 2050. This will effectively have a huge and massive demand on electricity if we assume that most of that cooling will come from the typical electrical split air conditioning units, individual for households. The estimations are quite chilling. 37% of all electricity demand, and these are averages, in the world will go for space cooling only. If we are thinking also that most of this space cooling demand and electricity load from air conditioning will happen at specific times of the day, we see that most, or at least more than half of the electricity load will come just to feed those electrical air conditioners. And that had significant impact on the electricity grids, as we saw recently in California, where there were massive blackouts because of a combination of issues, but at the core of it were the demand for cooling in that part of the world. And that drives us to where are we in terms of managing heating and cooling in cities. The UN environmental program, the UNEP, carried out a very interesting study in 2013 where they compared the levelized cost of energy for district heating and for district cooling as compared with decentralized production of heat and cold. On the left, you can see for heat, and the comparison is striking. You can see that less than half of the energy is used when you're having a district heating network than when you're having domestic individual heaters and boilers. For cooling, the difference is not so striking, but it's still substantial. Independently of the different technologies that you use, whether absorption chillers or electrical chillers, the demand and the cost for the levelized cost for cooling for district networks is much lower than whether you are comparing to commercial or domestic units. So what are the benefits of district heating and cooling systems as compared to the current and most spread individual units? We have a number of them. First, obviously, and we spoke about it, they are more energy efficient. For the same amount of energy that you put in the system, you're able to get more heat or more cold. It's estimated around 35% of energy is saved when you're using a district cooling system. Also, you're able to handle loads. As mentioned, when you are turning on the air conditioning, usually people do it at the same time of the day when they arrive from the office, or when it's in the middle of the day when it's hotter. And that has a specific impact on the electricity load of the country. The good thing of district heating networks and district cooling networks is that both they can shave the load, the upper graph, and they can shift it. So you are able to have a flatter load curve, which will reduce a lot and improve the efficiency of the network. District systems can integrate more renewable energy than individual ones, than going only through the grid network. You're able to balance through thermal storage much more energy. So variable renewable energy sources like wind or sun can be balanced more effectively. We're also able to save CO2 because it's more efficient. We can balance better the load, and we're able to integrate more renewable energies. Also, district units, particularly for cooling, use less refrigerants. I would say more polluting refrigerants as individual units, which helps to reduce the impact on ozone depletion, the famous hole in the ozone layer. Also, district units, they don't have fans at the top of the building, or they don't have fans outside of the window. So that noise, if we compare them in the whole city, is much lower. Essentially, we have a more silent city. Also, it's more reliable, it's more resilient, and it's more flexible. District units are able to handle changes in temperature, changes in loads much more effectively than individual ones. And finally, at the end of the day, it's cheaper. We're able to save much more money, even though the initial capex and the planning is more expensive. At the end of the life of the system, the savings are significant. And there is another benefit that I have in a different slide, which is essentially how are we seeing our cities. This is a picture from a house in Singapore taken in 2013, where you can see all these split units hanging outside of the wall. And imagine if you're able to have a city with a district network where you don't have to put all these things outside. Again, in Singapore, the whole Marina Bay area is cooled down by a district cooling system. All these beautiful buildings and all this beautiful planned urban area is cooled down effectively and without the ugly view of having split units hanging from every window. This is the whole Marina Bay district. All these green buildings are cooled by the same district cooling units, which I read somewhere that it's equivalent to 600 Olympic swimming pools of chill water per hour. That's the scale of the system. And this is from me, Xie. Thanks a lot for your attention, and hope Melanie now can continue with her presentation. Thanks a lot.
Thank you very much, Mr. Alfredo, for your wonderful speech. So he has covered a lot of details. He talked about cooling, energy consumption, and percentage of consumption for district heating and cooling and lighting and hot water. And also he has a lot of breakdowns for different sector for the power consumption. So we can see that you really has done very in-depth research in this field, and people has been listening to your presentation very attentively. As I mentioned, we have 220 or 230,000 people that is following our event online. And we have many technical hiccups. So carbon emission is not easy globally. So carbon emissions would mean a pain in terms of energy transition, and there is no easy task. We hope that we can turn the difficult task into an easy task. So, Madame Melanie, have you already prepared your slides?
很清楚。
We can hear you very clearly. Welcome, Madame Melanie.
So, thank you, everybody, and thank you for your tolerance. I'm very sorry for the technical issues we had earlier. I'm going to take a global view, and many of the previous speakers, in fact, all the previous speakers have very much helped me do my job, so I'll be able to skip through some of this. But what I wanted to really show is what we need to do to decarbonize the building sector globally, and show how China fits within that context. And to be honest, China provides a lot of the solutions that, of course, China needs, but the rest of the globe needs too as well. So just to have a look at the long-term net zero targets that people have been setting, we have a roadmap, as you probably know, to net zero. And I just wanted to show you this in the context of buildings. So the brown strip on here and the brown milestones are what we need to see happen in buildings. So by 2025, no new sales of fossil fuel boilers. By 2030, all new buildings need to be zero carbon ready. By 2035, most appliances and cooling systems need to be the best in the world. 2040, half of existing buildings retrofitted to zero carbon ready levels. And then we have 2045, half of heating demand being met by heat pumps. And then by 2050, more than 85% of buildings are zero carbon ready. So one of the important points in here, of course, is the mention of technologies and heat pumps, as well as other appliances and cooling devices, and I'll come back to a few of those in a moment. But this is also what we're looking at in this context. So we said that by 2050, over 85% of buildings need to be carbon ready, zero carbon ready, sorry, and we also need to be providing a huge amount of heating through heat pumps. And that's a development of technology that, of course, China has a huge part to play in. And we also need to make sure, so what we're showing here is that by 2030 we have new buildings and retrofitting buildings in the light green and the dark green, and likewise here on 2050. The really difficult thing, of course, is the retrofit of existing buildings, because as we've heard from others, they have a long lifetime, 30, 50, 70 years, and we lock in inefficiencies as we build these buildings. So it's really important to have measures that where we can retrofit to low carbon as well, and I'll come back to that too in a moment. So, our primary tool, as we all know, for energy efficiency buildings is building energy codes, building energy standards, generally applied to new build, but more and more they need to be applied also to retrofits if we're going to make these ambitious targets work. They need to be mandatory, they need to be extremely well policed in the sense of making sure that they really are applied well, and that they're not just a paper process. And we need to see them more and more incorporate not just the building fabric, but the equipment in the buildings. And also, of course, in some cases, they're starting to incorporate on-site renewables into building codes. So we would say that a modern building code needs to have all of those components. So that's our primary policy tool. Then, of course, in terms of the equipment within the buildings, as we said, heat pumps are going to be essential and will reduce emissions in almost all countries. Now, of course, hearing the previous conversations, this is a major business opportunity for equipment manufacturers. It's a major all around the world, and of course, particularly in China too. So those companies who can supply these heat pumps, good quality heat pumps at low cost, will benefit hugely from this transition. And of course, as we've just heard from our ADB speaker, of course, cooling is a growing need. It's a huge energy consumer today, but it becomes more and more so over time. These are some more charts from the future of cooling, which has just been mentioned. But this is looking at where we were when we produced the future of cooling. So 2.8 billion living in places where it's hot every single day, and only 8% of them have an air conditioner. This is looking at the evolution of air conditioner ownership. And again, this is a risk, a challenge, but also a business opportunity. So this is where we started. We see the air conditioner use growing as income grows. And this is where we see air conditioner ownership going in the future. And if you see that sequence event, once more, look at how quickly China grows in this context. So by 2050, 2/3 of the world's households could have an air conditioner, and China, India, Indonesia will account for half of those. That is a massive both challenge and an opportunity. Just to say that one of the worrying things is, although we're seeing really efficient products out there in the marketplace already, they're not being sold in vast quantities. So what we're trying to show here is that the blue bars, the vertical blue bars, are showing what the energy performance of the air conditioners are in the market today. This is slightly old data, but you can see a huge range. So if we take Europe, for example, it goes from the energy efficiency index on the right is a seasonal energy efficiency rating, and it goes from about 3 to about 11. That's a massive variation already on the market. But, the average product being sold is only a bit over 5, so it's about 5.5. So this is saying that we have the technology available today that can make this transition for us. We don't have to wait for new inventions. We don't have to, wait for companies to innovate. We can actually do this today if we get the right policy settings in place, and if we can convince our consumers or require our consumers to buy the more efficient products. So cooling is outpacing, of course, all other end uses in buildings. We heard earlier about how important heating is in some parts of the world, but cooling is where the growth is. And that's why we need to really consider this in our decarbonisation plans. And of course, I was asked to talk a bit about peak, and cooling has a massive impact on peak load, and it's very expensive, and it can have absolutely catastrophic effects on our electricity networks, and it has done so in many places. So in countries where they have fragile networks, developing and emerging economies, and they have this great growth of air conditioning load, it's breaking grids, and it will continue to do so if we don't do something about it. More energy efficient air conditioners, of course, will help cut emissions. We've seen that before. So I just wanted to touch briefly on the whole concept of looking at buildings and construction in a really holistic way, because what we often find is that people look at one element of this. We have a community that's responsible for building codes, say, or a community that's responsible for renewables. But what we don't see enough of is those communities actually working together. So we developed this methodology for looking at how you would decarbonise, with looking at today, medium-term and long-term plans. And it has these 8 themes. So we start with urban planning, because if you get your urban planning right, as we've heard in recent presentations, that makes a huge difference to the energy we're going to consume. Then we go through new buildings, existing buildings, operations, systems, the building materials we've heard a lot about today also. Then, of course, the buildings have to be resilient to whatever climate they're going to face, and this is in the long term. And then when we've done all of that to reduce the energy consumption as far as we can, we need clean energy, of course, to supply what's left. So we produced a global and 3 regional roadmaps. One of the regional roadmaps is for Asia, and there are some China considerations in there. But what would be great is to actually go back and tailor this approach to China so that you can take this holistic approach. And that's what we would advocate, is having a look at this methodology, looking at the short, medium and long term, and across all of these areas from the beginning of buildings and construction going all the way through the value chain. And then just quick conclusions. You've heard a lot of this today, but China's had the most impressive economic growth story, lifted hundreds of millions of people out of poverty, and is the world's largest producer and consumer of energy, as well as now the world's largest emitter of CO2. Of course, there's the carbon neutrality pledge, and this is going to require a major transition, introducing renewables at a huge rate, but that's already started. And as we've already heard, though, China's made huge efforts to bring down the costs of many lower energy efficient and low carbon technologies. China's made remarkable progress on renewables in particular, of course, solar and wind. But we need to have that continued success with the energy efficiency technologies we need, with the air conditioners, with the heat pumps, with the building materials. And we've heard some great presentations about that as well. So what the good things are that, this doesn't have to cost, it doesn't have to cost the earth. An orderly clean energy transition can result in huge multiple benefits. So about 1 million net additional jobs by 2030 through this clean energy transition. And what we would say is that buildings is one of the best places to invest, because you get more good quality local jobs by investing in buildings than you do in any other part of the clean energy process. Of course, we've said that buildings and building services need to be as efficient as possible to play their role in this transition. But we also need to innovate as well. And we saw this in the first presentation today. Digitalization and advanced building controls, the introduction of AI, we now mean that buildings can become a flexible resource and they can be integrated as part of the overall energy system. And that's where the future lies, and that's what we need to work towards collectively. I would just say we do have one challenge, and this is of course close to the heart of ADB and others. Investing in buildings energy efficiency at the pace and the scale that is needed is still a major challenge. And I will just leave you with that thought. Thank you very much for your attention.
Thank you very much, Madame Melanie. So after patient waiting, we have got your very wonderful speech and presentation. Thank you very much, Madame Melanie, for your patience, and thank you very much for your insightful presentation. I agree with you in terms of building lifespan. If you look at the average lifespan, it's about 50 or 80 years, or less than 100 years. Well, if we can extend the lifespan to 1,000 years or even 10,000 years, then this would be the most valuable contribution for the Earth, and we have delivered that. For example, our broad hollow building, its lifespan is 1,000 years. It can reduce the construction waste and construction materials, and if you have time, you're welcome to visit the broad city, and we can have a further discussion. Lastly, I'd like to invite Mr. Omid Saberi, the green building specialist of the International Finance Corporation of World Bank. He is going to talk about EDGE certification. Welcome.
Hello, good afternoon. Here I wanted to present to you the program on practical steps for zero carbon buildings using EDGE, and this is part of the work that has been done within the World Bank Group. Before starting, I wanted to introduce myself. My name is Omid Saberi. I'm Senior Green Building Industry Specialist and Global Technical Lead for EDGE program. I'm based I'm part of the IFC's World Bank Group, and I'm based in Washington, D.C., United States. The first question is, what is IFC? IFC is part of the World Bank Group, the private sector arm of the World Bank Group, and provides support to development projects around the world through financial solutions. I'm also part of the climate business department of IFC, which supports climate projects. Specifically, I work on green buildings. Before we start, we just want to make sure that we cannot tackle climate change without tackling the building's emissions. Buildings is the elephant in the room, is the largest piece of puzzle, but also at the same time, it's the most complex part of puzzle to be solved because there's lots of players in the building sector. The World Green Building Council has set two targets for all new buildings, and they need to be zero carbon by 2030, and all new and existing building needs to operate at zero carbon by 2050. And within next 28 years, we need to convert all our buildings, including the buildings that we live in, the workplace, schools, hospitals, every building should be operating at zero carbon. And this requires certification support, corporate and government support, training and education, and different players to come together. If you look at the number of zero carbon buildings globally, it's not, it's nowhere near where we should be. There's a huge undertaking that needs to be done. But at the same time, this is one of the largest opportunities in climate sector where it can generate jobs as well as generates new businesses and new industries. What we have been doing within IFC is called IFC's Green Building Market Transformation Program. IFC's Green Building Market Transformation has 4-part strategy. Number 1 is the part that we support through our direct investments, buildings to be transferred from normal buildings to become green buildings. We already invested more than $6 billion directly in green buildings through our direct investments. We also with the banks, work with the banks, commercial banks, and our work with them includes instruments, financial instruments to support green building investments. We work with the green building codes and incentives with governments, and governments through the city government or federal government or national government can support increasing number of green buildings. And finally, we work on EDGE certification, which is a solution to certify buildings and is a way that connects all these elements together. So what is EDGE? EDGE stands for Excellence in Design for Greater Efficiencies. It has 3 elements: a free software, a standard that is achievable, and it has a verified green label or certificate. The free software is available to everyone. It's free of charge, and it's an added value for public good that everyone can use around the world to design their buildings and build buildings as per the requirements in the software to become green building. The standard is very simple. It has a 20% reduction for energy, for water, and for materials, and that 20% is from a local baseline for each city, each building type. And once that standard is achieved, which software will show whether a building achieves that standard or not, building can get certified. And the certificate is very transparent and is done through multiple levels of quality control and quality assurance, therefore giving the peace of mind to the government as well as to banks to accept this certificate as a quality standard. EDGE can be used in a variety of building types, from homes to hospitals to retail, warehouses, all sorts of buildings. What is important in EDGE is that you can use EDGE even in a social housing that is 40 square meter, all the way to 5-star hotel, for example, or resort. You can use it for a small kindergarten or school, or you can use it for large shopping mall or department store or airport terminal. We also have seen, because of COVID, a lot of interest in the warehousing sector, including in China. We have been looking at warehousing to expand the number of warehouses with green conditions. There are 3 levels of EDGE certification. The base level is called EDGE certified. EDGE certified is, as I said, 20% reduction in energy, water, and materials. If you improve the energy efficiency higher to 40%, then that building can get certified as EDGE Advanced. EDGE Advanced is the 2nd level. We also call EDGE Advanced as zero carbon ready assets. So that asset then can apply for zero carbon certification. I will explain how a building can get to zero carbon from EDGE Advanced level. So when a project being certified as EDGE Advanced, it means that it tried to achieve the maximum efficiency on site. sometimes it's not possible to get beyond level of efficiency on site. So that's why we make sure that the 40% is there for achieving efficiency on site. There needs to be operational data and occupancy. So the occupancy and real consumption of energy and water and other, all the carbon emissions are very important. Using that data, then they can use off-site renewable energy or, as a last resort, carbon offset to achieve zero carbon certification. The good thing about this type of certification is that it can be done in the center of Shanghai where you have high-rise buildings, or in Beijing, or in a village. So anywhere you can use zero carbon certification by EDGE to certify assets. You don't need to have big land to use a lot of solar system. It can be used in any project. This is a certificate, zero carbon certificate, that shows a lot of data around the real consumption of the energy. It shows the carbon offsets. It shows the validity of the certificate. This certificate needs to be renewed every 2 years to show the continuous verification of zero carbon condition. EDGE certification is available for the design of the building as well as for construction. You can also use it for operation with zero carbon certification. This process is very efficient. We have projects that have been certified within few weeks. So the process of certifying at each level is very efficient. There would be a design audit and construction audit for the auditors to inspect the building. It's also important that EDGE can be used for existing buildings. You can certify an existing building, or you can retrofit an existing building and meet EDGE standard and certify it. There are a number of case studies on our website that you can refer to. We already certified more than 28 million square meters of projects, and we certify roughly around $1 billion of projects every month using EDGE. And this volume is amazing because it generates the new asset classes for the banks and for also for the users, for the benefit of the users. The other piece that is important to mention here is what we are seeing with the portfolio clients, with the large asset owners, either private sector or public sector, either large companies, that they have large portfolio of assets, thousands of assets. EDGE can be used quite easily to identify, to pre-assess all these assets, identify their level of performance, and set a plan to improve the performance, and then move them to zero carbon. So it can be used to plan by when you can get to the level of standard of EDGE certified, by when you can get to EDGE advanced, and also to zero carbon certification. EDGE already approved by International Green Finance Standards for green buildings. You can see that EDGE is approved by ICMA, International Capital Market Association, Climate Bonds Initiative, GRESB, CDP, and all of these help the banking sector to easily use EDGE as to issue green bonds, to issue green loans, or green mortgages. These are some examples of the work that has been done, and the banks like HSBC, ProCredit, all the banks that issued green construction using EDGE, green construction loans, and green mortgages, or issuing in the capital markets, issuing green bonds. So green bonds issuance can be done by the banks, or it can be done by the private sector companies. In China, we have been working in China with MOHART and CSTID. We started working with them in 2015, 2016. This is one of the points that we did the expert review of Edge baseline, and we updated Edge baseline specifically for China. In China, we have Hong Kong Quality Assurance Agency, GBCI, Sintali, and SGS certifying projects for Edge in China. We already trained Edge experts and auditors, but there is room for training more engineers and architects to learn about Edge and apply it to their projects. And these are some of the projects that have been certified in China. This is Johnson Controls headquarters in Shanghai, which was certified as Edge Advanced. It's one of our early Edge Advanced office buildings, impressive building that was certified by Edge. It was also certified by LEED Platinum as well as 3-star, China 3-star certification. This is another example of a bank, ProCredit, that certified their own buildings, their own headquarters, as well as their own branches, and they are looking at using Edge for green financing with their own clients and green mortgages. So it's an instrument that can be used by the banks as well as by private sector companies. Edge also, beside Edge, we have been working on Building Resilience Index. This is a program for climate adaptation to identify, manage, and disclose natural disasters risk in buildings. And stay tuned, this is a new initiative by IFC. Our program is supported by UK aid as well as by Swiss government. We are thankful to all our donors that support Edge program globally. I want to thank you for your attention to my presentation, but also I wanted to request you to check our website, edgebuildings.com, as well as follow us on Twitter and LinkedIn on Edge Buildings. Thank you so much and have a great afternoon. Bye-bye now.
好，谢谢奥米的先生的精彩
Thank you, Mr. Omi
让
Seibert.
我们
Thank you for your
更多地
wonderful
了解了
speech,
作为宜居绿色
which
建
help
筑
us
真正的
understand
法
more the Edge
未来的一
certification
类的方
on
向
green
非常
buildings
精
and
彩
also the future
尤其对
orientation.
我们这个
Thank
视
you.
频调控的影响我们这下午的活动
Because of
延
the
迟
technical
了
issues,
30分钟没有关系
our
那么
session was
前半部分
postponed for 30
主
minutes,
题演
but
讲嘉宾呢就全部结束了
actually we've wrapped up the keynote speech session.
有绿色企业的建议
They talk about the policies,
绿色认
practices, and green
非常
certification,
丰富
green
好
energy,
我们
and so
下
on and
面
so
的茶
forth.
歇20分钟
Very
现在是
impressive.
4点
So we're going to have a 20-minute tea break.
4点
It's
25我们正式下午
4:05 now, so we will resume our conference at 4:25.
最高的研究机构建议
The
院的专家
representatives
还有来自新加坡的
comes from the
专家
local companies in
来自4
Hunan
个
and
的
also
专
the
家
experts from Singapore
那
and
个
also
非
World
常
Bank.
精彩我们会有互动好请大家
And we are
茶
going
歇
to have a panel
20分
discussion
钟谢谢
after 20 minutes. Thank you.
你好，请各位听众朋友，就是耳机不要带出去，从传耳机不要带出本会场。
Please leave your simultaneous interpretation headset on your seat. Please do not take it outside the conference room. Thank you.
Melanie, Alfredo, thank you so much for joining the first part of the session.
I'm sorry that it was so complicated. I don't know what was going on, but okay, thank you anyway, and I'll
with a panel discussion.
下半场呢有4位参加圆桌
4 panelists are going to participate
分别是
in the discussion.
来自新
They
加
are
坡国立大学设计与环
Professor
境学院的
Li
院
Peng
长
Lam,
林启
Dean
波先
of
生。
the School of Design Environment of National
我
University of
先介绍
Singapore.
一下4位嘉宾，然后我们再掌
So I would
声
like
欢迎
to
嘉宾
briefly
之后
introduce
和
these
连
2
线嘉宾
panelists before we start the
第
discussion
2位是
officially.
来自我们
And
湖
the
南
second
这个
panelist
中国建研院低碳建筑研究中心的主任
is Director Deng Gaofeng.
邓高峰女士。
Madam Deng Gaofeng, Director of Low Carbon Building Research Center of China Academy of Building Research. And the third panelist is
后面的介绍有很多，
Chen Hao,
每个人的介绍里面呢都有
Deputy General Manager of Hunan Construction Engineering Group.
陈浩先生。第4位线上
And the
的
fourth
第1位线上的
panelist
第4位线上的
And also the first panelist from Singapore, they are joining us online, is Paulo Lopez,
骆佩斯先生。
Director Strategic Partnerships of Greater China BSI.
现场的2位嘉宾就座，线上2位嘉宾连线，
So
欢迎。
A warm round of applause for our panelists. Very impressive lineup.
到论坛的最后，连得又快，图像又清晰。
As we can see, we are moving towards the end.
2位先生，
Now the technical problems have all been resolved. Hi, good afternoon. Hey,
好，哎呦，
would you please? Wow, you speak very good Chinese. I'm gonna switch back to English when I speak up.
那个这样的程序啊，圆桌论坛呢，
So for the panel discussion,
虽然没有圆桌在，
it's a round table. Actually, we don't have a physical round table here.
3个步骤。第一个，
So
嘉宾每人
first of all,
5到8分钟。
each panelist is going to speak for 5 to 8 minutes about his or her view on low carbon and also carbon peak in the building sector. And then, in the second stage, we are going to have a live Q&A.
台上台下，线上线下嘉宾，我们互动。
Which can be conducted both offline and online. And in the end, in the final stage, I would like to invite all the panelists to speak very briefly about his or her view
首先，
on the dual carbon strategy.
新加坡国立大
The first panelist is Professor Ki Peng Lam
齐波先生
from National University of Singapore. Thank you so much. It's been 2 years since I came to China last time, so I don't have any opportunity to practice my Chinese. I'm afraid I could not speak Mandarin that well. Therefore, I'm actually looking forward to my visit to China again, so I can practice using my Mandarin. And forgive me, I have to switch back to English in order to express my views more clearly. So I'm going to talk about some of my research programs.
First of all, I want to thank Broad for their kind invitation for me to share in this dialogue session this afternoon. First of all, I have known Broad for more than 20 years. When I was a professor at Carnegie Mellon University, Broad was one of a very strong supporter of the research in our Center for Building Performance and Diagnostics at Carnegie Mellon University. And at that time, we were studying solar thermal absorption chillers and doing a lot of research and testing of those systems. And this is 20 years ago. And so I'm not surprised to continue to see the amazing advancement of work that the company has done over the years and continue to do, always pushing the frontier of technology, of low carbon development for the building industry. I think it's a tremendous effort, and we should all be to congratulate Broad for doing that work. So the topic of this Q&A have been focusing on industrialized building or prefabricated buildings as one way to address the carbon content of our construction industry. Again, I'm a strong supporter and believer in industrialized building. When I first graduated as an architect in England in 1982, my first job was to work for the government office to apply industrialized buildings. And since then, I have always strongly believed in the many, many benefits and advantages of industrialized buildings that the speakers in the earlier session have elaborated. I don't think I need to continue to repeat many of those advantages. However, I want to raise 2 points just in this short introduction. First point is to go back to the fundamental reason why we build buildings and why we build cities. Because sometimes in our excitement to adopt technology, we may forget the reason why we are building. And the reason why we are building is to support and provide for the people. So the first point I want to make is the human-centric or people-centric approach to the way we create, design, construct, build, and operate our buildings must constantly be reminded of the needs of the people. And the needs of the people are quite simply represented by 4 important criteria. One is our physical well-being, what we call the physiological requirements to keep us healthy physically. Number 2 is to keep us psychologically healthy. I think COVID has taught us many, many lessons, how important our buildings are to cater for these 2 human conditions. Third is the sociological requirements. We are not individuals. We always exist as a community, as a group of people, whether it's at work, whether it's in a family, whether it's in our neighborhood. So the sociological support is very important. Of course, last but not least, the economic well-being, which again, I don't think we need to explain. Everybody understand that. How to promote and in our built environment, the economic well-being. So this is something that the first point I really want to share. So that everything we do, every idea or technology we introduce always must relate back to what benefits do we get from to the people, okay? Number 1. Number 2, also we must remember a very important principle. In this world, there is no free lunch. 在中国人来说的，天上没有白吃的午餐啊。
There's no free lunch, as the Chinese saying goes.
Somewhere. Just a question of how do we distribute the resources in order to create an optimal deployment of the rare and very often very rare and limited resources that we have. Now, I'm from Singapore, so I can say this as a matter of fact. As a country with zero natural resources, we have to create a country that can survive. So it's really, really critical that we apply this holistic thinking or life cycle thinking in the way we build our buildings and our cities. Again, many speakers have addressed that, and that's something that I don't need to elaborate. You see, our human behavior naturally is quite wasteful, I have to say. If you look at our current energy system in the world, we take the raw material and we convert the raw material to energy, and then we send the energy over long distances to the end user, who then use the energy, sometimes effectively, sometimes not. If you track the beginning to the end of energy use, from the raw material to energy use, and people have tracked that, more than 50 to 60% of the energy is wasted. We only effectively use about 30 to 40%. I'm talking now about the whole system. So we need to take care of the front part of the energy story while taking care of our building story, okay? So that's the second point I really want to make, that we need to look at the life cycle. As we pursue more industrialized building, we must begin to pay attention to the energy we use in our factories, in our industries, to make those buildings, so that we will always be mindful and conscious of the total energy system, because that is what nature constrains us. There is no free lunch. So let's pay attention to that as we talk more and more about technology in its many forms in our building industry. Okay, I will stop there. Just want to make those couple of points. Thank you.
好，感谢。
Brilliant. Thank you. Thank you, Professor Lam.
好，接下来我们有请中国建筑研究总院
And the next panelist comes from China Academy of Building Research, Madam Deng Gaofeng. Good afternoon. Good afternoon, everyone. And actually, the full name of my institution is China Academy of Building Research Co-Limited. So maybe you thought we are a research institute, but actually before the year 2000, it was the case. But during the year 2000, we have been transformed into a company that is directly under the SASC. But still, we specialize in science research in the building sector. And after I listened to Professor Lan's speech, and although he is an architect, but I am not. You know, I studied industrial analysis, and I graduated from the Tsinghua University. My research focused on waste incineration for power generation. Yes, it also has something to do with environmental protection and also energy. And also back then, you know, I was sort of reluctant to be involved in the business. You know, it was not very easy for a girl to work so hard on the construction site. So I decided to go abroad to pursue further study. But actually still, 80% to 90% of our time is spent indoors. And then I decided to focus more on the indoor environment. So that was why I came to China Academy of Building Research. I've also been I've also known Broad Group for like 15 years. And when I first got contact with them, they were specialized in air cleaning systems. And now they come up with a series of new products like the column, the liver building, the slab. So then my focus began to shift from the indoor environment to also energy efficiency, and also how to use energy in the buildings, and including the utilization of renewable energies in the buildings, etc. And back in 2013, China launched a campaign called Green Ecosystem, Green Eco Cities campaign. And the carbon emission of the buildings actually contribute about 30 to 50% of the total carbon emission in my city. So then I think it is meaningful for us to see what we can do to reduce energy consumption and carbon emission in the buildings. And that was why in 2014 we established the Low Carbon Building Research Center. When it was first established, my boss and also some of my colleagues always ask me, what exactly do you research on? And actually, last September, after President Xi Jinping put forward this dual carbon strategy, and then people was more familiarized with what my research center is doing. And I think carbon emission from buildings is worth studying, and we pay attention to environment and also energy. Professor Lam also said that we need to remember why we built the buildings and the cities. We need to keep that in mind. And Mr. Qiu also gave a speech previously which expressed a similar idea. Now, back in history, we live in the buildings made by the mud bricks, by the wood, by timber, and even by straw. And now, the building and construction industry has gone all the way, and now we are using different kinds of materials to make the buildings. And I think the major drive behind all this change is our desire for a better life, for a better living condition. So how to make the living condition more comfortable, more healthier, and also how to make the buildings more cost-effective and sustainable. I think that would be the major issues that we are doing research on. And some people say that if we adopt a new technology, it might make the environment better, but still it may increase the energy consumption of the building. So we also need to do a research to see how we can strike a balance between the two. And also in terms of a zero carbon building, how can we achieve that? Shall we replace the energy with renewable energy, or shall we adopt different facilities? I think there are a lot of trade-offs and balances that we need to see how we can achieve that goal. And actually, I originally prepared a PowerPoint for this slide.
So I want to talk about what are the things we need to watch out for the green buildings. There are 6 points. First, that is the maintenance structure. Well, in Peng Ji's presentation, he talked about insulation. So how can we make sure that the building is much more insulated and also build better envelopes? This is something that we need to do for the first step. And second, that is high efficient and high performance construction equipment. If we use more energy efficient products, then we can make much more energy efficient buildings. For example, we use LED lights, and for the light guiding panel, we can use materials with lower energy consumption. And also for AC, for electrical equipment, we want to make sure that those products are energy efficient. Third one is renewable energy. The country is proposing compulsory standards for the new buildings. For the new buildings, they need to have a PV system, and for wind power, geothermal power, and other renewable power, they have to be adopted by the future buildings. And this should be the source for the future buildings in terms of energy generation. And fourth is a smart system, especially smart management system. We hope that it is distribution based on demand, and it should be people-centered, and it should be demand-centered. The current sensors have been very advanced. We hope that the data sensed by the sensors can provide us with input and strategies for power management in order to reduce waste. And we also have a new technology, and we can combine it with renewable energy. And if I have more time, I can share with you a small example. And people think that the smart system can provide more convenience for our life. And in my home is a totally smart-based system, and we have achieved a zero carbon building standard. We have PV system, and the heating and the cooling are powered by pumps. We also have smart outlets and pockets for the system. But my mom is against those smart things. For example, my boiler has a really large power consumption. For example, we set a standard, which is we should not use it before 9 a.m. Because for the PV system, the power generation would be larger than 200 or 300 kilowatt hours after 9 o'clock. And my mom is not very happy with that because I have certain conditions for using the kettle. But if my mom wants to use the kettle in the morning, then there will be a warning signal, and then the kettle would be cut off. And my mom would wait. Why there is no hot water? It's because I have a remote system to control the use of kettle. So my mom complained a lot. And my daughter is also not happy with my smart system. So especially during the holiday, there was also a working day during the holiday, and she wants to watch TV. But for the TV at my home, there is cutoff of TV at 10 o'clock because she wants to watch the National Day Holiday Gala. She wants to watch the performance of her idol. And then at 10 p.m., the power was cut off in the living room. So this kind of smart system is not human friendly. Actually, it will not bring good experience for us. So in the future, the smart home appliances should be much more smarter and meeting our requirements, and we need more training for them. And especially in terms of understanding our preferences and habits of using the appliances. This is something we need to research in the future. Fifth point, we need to have a circulate economy. If we want to achieve zero carbon building or low carbon building, then the wastewater or the sludge should be circulated and recycled. This is a very key point. Lastly, when people talk about zero carbon, people will talk about carbon sink or carbon trading. This is the ultimate step. And firstly, we need to look at building-related effort, especially the first step. This is the things we need to do in the future. And today I learned a lot from previous speakers' presentation. And we have another topic 2 days after this conference, that is Zero Carbon Village. Hunan is the hometown of Chairman Mao, and he said that we need to use the village to encircle the cities. According to our practice, in the villages, it's much more easier to achieve zero carbon building or zero carbon city. And I hope that in the future we'll have more people to work with us to commit to zero carbon village or town. And this will be much more helpful for our low carbon building transformation so as to contribute to carbon neutrality and carbon peaking. Thank you. Thank you very much. Really good points proposed by Madame Deng, and also she shared personal stories, really refreshing and memorable. And now let's give the floor to Mr. Chen Hao, who is from the Hunan Construction Engineering Group. And he has a lot of experience in construction management and building. He's also the chief engineer, and also he is the deputy member of the Building Council, and he is the expert for reviewing the Luban Award. So I think he has a lot to share with us. And the floor is yours, Mr. Chen. Dear friends, dear colleagues, good afternoon. It's a great pleasure to attend this parallel session. I've heard the insights from different experts regarding low carbon, carbon emission, and industrialized building. And I agree with many of their points. Also, we have seen the Holong building of the Broad Sustainable Building, BSB. I personally have participated in the design of Holong, especially the stainless steel slab, the B-core slab, and also the relevant technologies related to B-core slab. So taking this opportunity, I'd like to share my own views and observations. First of all, a few words about Hunan Construction Engineering Group and my work. My group focuses on construction business. For 3 years, our revenue is over 100 billion, and we rank top 200 among the top 500 companies in China. And after graduation, I used to work for the group, focusing on R&D, production, and management. And I have been working with this group for 31 years. I've never changed my job. Apart from the operation, production, and management, we also have relevant teams focusing on business related to the industry policies like green construction, green building materials. And second, the beam-based smart construction and R&D work related to that. So smart construction has been incorporated into the design and maintenance and production phase with our own IPs. We have a lot of management tools and approaches, and the industry has been booming, and it has a separate company, and it has settled down in the industry parks. So smart construction and digital transformation of the company and the smart society development have been developed in tandem. So that's the work of the second R&D team. The third one is prefabricated building. We also have a team on that. For example, we have concrete and steel-based prefabricated building. And we have a lot of research in this area in order to build a complete value chain. So I don't have to dwell on PC. People have talked about that a lot. In terms of steel-based prefabricated building, we have similar ideas with Broad Group. Currently, the product offering like hollow building is more advanced and more system-based compared to our product offering, and they are using stainless steel. We use the traditional steel, but we have a cost advantage. Well, our cost advantage is based on the current design life, which is 50 years. If you look at the longer term, for example, 100 years, the design life of hollow building is 100 years. If you look at this lifespan, then the system of Broad has its own cost advantage. For the steel-based prefabricated building, I think Broad Group has a really good example of a modular design or modular application. And we're following the same idea. We have two projects currently which have passed the design and administrative licensing, and they have met all the construction process requirements. One is a publicly rented house. The other is for Hunan company, which is a construction project. It's a middle school construction, about 20,000 square meters using our own module. And we think that we do not have the advanced technology as the Broad Group. Well, for PC and steel-based and wool-based building are the key components of prefabricated buildings, especially for wood-based building. And wood-based building has been gradually phased out in the past few years. Well, carbon emission control is very important. Carbon peaking and carbon neutrality require more advanced technologies. So for the traditional wood-based building, actually those new targets will bring new opportunities. For many of the building materials, they are the source of carbon, but for wood-based buildings, they are actually a carbon sink. So they will help to achieve carbon peaking and carbon neutrality. So we will use our own construction project, that is a kindergarten project. They will be wholly based on wood, and one would be a prefabricated module, and we will do research in this regard. A few months later, this building would be finished, and we hope that you can visit the site in the future. So these are the outcomes of our research. Well, regarding our theme today, we need to be very clear about one point. Green and low carbon and carbon emissions, carbon peaking, carbon neutrality are our targets. And smart building and smart approach or digitalization are the approach to achieve these targets. industrialized production is a means, and green and low carbon materials R&D should be the basis.
I think Broad Group is doing a good job by starting with using new materials, the sandwich structure slab. Actually, the carbon is not reduced in making the lab itself, but since the lifespan is extended tremendously, so here we can see that the carbon emission reduction can be achieved from the entire life cycle of this product. In the past, we were talking about green materials for construction without odor, without the toxic materials, for example. But now, low carbon has also become a major consideration for the building industry, which is gaining importance and which, in my opinion, should be a most effective way for us to attain carbon neutrality. So as I said, we need to have the target, the approach, and also the material foundations. With all those together, we can successfully achieve the target, which has become a common goal for not just China, but also all the countries in the world. And also, I think all this topic that we've been discussing, it's easy to talk about them. It's easy to say things, but what's more difficult lies in the practice, in the implementation. I think the building owners and also the developers, construction companies, they should all play a role in this endeavor. And also, I think the biggest drive for realizing the carbon reduction targets lies in them. Different groups and stakeholders and players should all play a role based on the national conditions, and also now, like Mr. Deng said, Madam Deng said, actually now, after we have all the technologies, we should have a people-centered approach. And also we should see how we can put those strategies in practice and apply those technologies in the real case scenarios, right? And for that, we would like to see a greater participation of all different players. We want to see everybody coming in and play a part in order to attain the low carbon and even carbon zero targets. And we do have the national support, the policy support, and still we want to see more incentives and the supporting mechanisms, so we can actually incentivize the construction companies and the building owners to put in place all those very good initiatives that we are having right now. Okay, so it's easier said than done. That wraps up my speech. Wow, that's very impressive. Action speaks louder than words. Now let's move on to our last panelist. Last but not least, Paulo Lopez, the Director of Strategic Partnership, Greater China, BSI.
大家好. Good afternoon, everyone. It's a real pleasure to be invited to speak at this conference. This is a extremely important topic, and as we heard from all the speakers. And it's very important for all of us to understand exactly how to achieve carbon neutrality and how to achieve the great goals that we have in front of us. I'd like to share a little bit more about what we do at BSI. And I'm going to share my screen if you should be able to see it now. So I'm Paolo. I'm working with BSI. I'm based in Beijing, and unfortunately, I was not able to see and join you in Changsha. But I hope we'll have a chance to meet in some other occasion. At BSI, what we do is we have a purpose, which is inspiring trust for a more resilient world. So everything that we do is about creating trust between organizations and building resilience within the organization. And we achieve this through standards. We are a standards organization. Actually, in the UK, we are the national standards body. It means that we create the standards in the UK and we implement and manage the standards in the country. Globally, we also have a presence, we have a global presence. And we also do assurance, which means training and certification, and also professional services. In China, we focus on certification and training. And very quickly, our origin actually comes from Sir John Wolfberry, who is actually the engineer behind the Tower Bridge in London, and is the founder of BSI, so 125 years ago. Through our journey, we created in 1901. In 1946, we were also a founding member of the ISO, the International Standards Organization. And in 1995, we entered China. So we've been in China for 35 years and working with the Chinese government to develop standards in the country and also helping the Chinese government to bring standards at the international level as well. We have a global presence with over 85,000 clients and spread around the world. In China, we have around 300 people spread throughout the country. So I'm based in Beijing, but we also have offices in Shanghai and Shenzhen and other cities. And worth understanding, as we're a standards body, we also create standards. So many of the standards that we created actually became ISO standards years later, including some of the most famous and used standards in the world, like the environmental management, ISO 14001, or energy management, as well as carbon neutrality, which I'll be talking more in details later, past 2060, which will become an international standard in ISO 14068 in 2023. And our focus is really about, we have a few areas where we focus our strength. One is on the food sector. The other one is on information security. The other one is on autonomous vehicles, AI, IoT. And then the most important one for today's topic on sustainability, as well as the construction sector, the built environment sector. And actually in China, because understanding very well the markets and developing a strategy just for the country, we've developed some solutions helping every organizations in China. So one of them is on information security. The second one is about smartness and IoT, which also include the BIM, the build information modeling, and all the related IoT that goes into a building and into the construction. As well as sustainability, more specifically on carbon neutrality, on how to achieve it, and how to measure the carbon footprint, and how to manage and reduce carbon emissions. And finally, on international compliance, to help to ensure that any achievement in China can be recognized internationally. And over the years, we've been working very closely with the Chinese government, helping to create a mutual recognition between the standards, the international standards and the Chinese standards. Over the years, we've helped to adopt 62 standards as global standards. And we are continuing this partnership with the different entities to help to ensure that standards are recognized internationally and can help businesses to conduct business internationally as well. As we talk today's topic, we're talking about climate change and carbon neutrality. This year, COP26 will happen in the UK. It's a very important event organized by the United Nations, where all the heads of states around the world will join on-site or online to show their commitment to climate change. The Paris Agreement was actually signed in COP21 in Paris several years ago, and we expect quite big announcements this year in the UK. At BSI, we take a role in helping to shape the discussion around standards from a standards perspective, and we have also certified the event against ISO 2121, which is an international standard for sustainable management for events. And I think it's quite important to understand why standards are important for companies and how can companies benefit from the standards and being certified. So one of the obvious benefits is around promoting trade. So especially between companies, between organizations, and between countries. With this, they also enable innovation, and they promote productivity by being able to bring the best practice from around the world into the organization. They're also there to protect the consumers as well, to ensure that the standards are met and any risks are reduced. And finally, they offer a support to regulators. So countries use standards, or associations use standards to help to regulate industries, products, and organizations. In the built environmental sector, there are a set of standards that can be used to help construction companies, architects, design, including the whole supply chain, to become carbon neutral, to achieve all the co-benefits around carbon neutrality and the ESG as well, and finally be able to grow their business. So thank you very much. So this will be my introduction, and later on I'll be happy to discuss a bit more about actually how to achieve carbon neutrality and how to be able to demonstrate it through standards. Thank you.
保罗先生介绍得非常好。
Excellent introduction. Yes, I agree that we are seeing the different kinds of standards in the world. The US has their standards, the European countries have their own standards, and China has its own standards as well. So how can we actually bring all those different standards in line and to successfully help us reduce carbon emission? I believe that's a very important issue. Thank you very much, all the four panelists. Thank you for sharing your insights and observations. And now let's start the second stage, the Q&A. All right. And if you are joining us online, you can actually type your question in the chat box. And then the staff will hand me your question on a piece of paper. So I will ask the first question as the moderator. Any one of you can answer that question of mine. A few days ago, An expert said that he is over 60 years old, and he still remembered the houses in the rural areas that he used to live in as a child, with very thick walls made of mud bricks. And back then, you're seeing more vegetation in the rural areas in China as well, and the snow heavily in winter. But inside the house, it was quite warm because the heat insulation was very good.
And now we have more and more buildings, and the buildings are getting more and more thinner. And in the winter, without heating, it's very uncomfortable. In summer, without cooling, it's very uncomfortable. And we have cases whereby people cannot stand the heat or cannot stand the cold. But in the past, actually, you don't have to use cooling or heating. Well, it is because of the insulation technology that has affected the building performance. Can anyone answer this question? Why the insulation performance is so different at present and in the past? Well, I talk about the low carbon building. Firstly is the high performance envelope. So that it means the wind will not be let into the building. And there are two parts to it. That is a non-transparent envelope. That means the wall should be insulated. But how should we achieve that? In the past, we have the rough cast house, and there are some straws, and you can lay a thick layer of straw for the rough cast house. And for the constructors, they need to have a requirement for plot ratio. If the wall is very thick, then the space inside would be very small and would be smaller. And if you buy a house of 100 square meters, but it seems that my usage space is less than 80 square meters or even lower, 70 square meters. It's because the wall thickness has an impact on the actual space of the house. So the walls are getting thinner and thinner. And now we need to ensure insulation. For example, if you have an insulated layer in your building, then the plot ratio would be reduced. And I can give you incentives. So the government is using those incentives so that the walls are thicker and the insulation performance is better. Including for our construction materials, they are developing the materials with the lower thermal efficient and high performance insulated materials for prefabricated buildings. They are also hoping to ensure a better insulated layer. One, to reduce cost, and second, to meet the standards. But the point is the energy consumption and the cost and environmental protection and energy consumption should be balanced. How to get the balance right? This is something we are working on at the moment. And people are saying that we are developing the biotic building, or in China, we found that in many of the rural areas, they are actually living in the caves. For example, in the western region, they are living in the cave dwellings, and they can have electric heating beds, and that will help them to go through the winter. And when you do not use coal in the cave dwelling, there would not be any poisoning events. So I think we need to be location specific and do not forget why we started. Whether the wall is thick or thin, the ultimate purpose is to provide a comfortable environment for people to live in. If we can achieve that, whether it's a modern building or rough cast building, whether it's wood-based or steel-based, then that doesn't matter. As long as we can achieve the target, it doesn't matter which means we use. That brings to another topic. So the regulators have to change their mindset. So the current buildings are actually looking at the construction space and thickness of the walls. So just say if the house is 100 square meters, if we exclude the thickness of the walls, then the actually usage space is 70 or 80 square meters. For Hong Kong, their price is 300,000 RMB per square meter. Actually, their calculation basis is the net space. And I have a friend in Hong Kong who buys a house with a space of 50 square meters. Actually, it's the equivalent to a house in Beijing with a space of 100 square meters. Because in Hong Kong, the calculation basis is the net usage space. I don't know whether it's the same situation in Singapore. Well, yes, globally it's the same. What's your view on this question? Well, about my own view,
a global real estate issue and challenge. What are we buying and selling? I have given a talk some months back. Because of COVID, I said we should be buying not square meter, but cubic meter. We should be paying for volume of air, not square meter or space. Because what affects all of us in the COVID condition is the ventilation and the air. I think that's one very important mindset change. I hope that the real estate industry will begin to change the value of how we measure our, buildings. So I think that's one point. It's a global issue. Now, I want to add on earlier the discussion about design. To me, it's really important to focus on what I call climatic responsive design, instead of adopting what architects might want to call international style. It doesn't matter whether you are in Beijing or whether you are in Alaska or in Singapore, we build the same building. Clearly, that's something wrong, in my opinion. Yet, this is being done again and again, which created this problem of energy and comfort and health, because we are building in a way that is not responsive to the local conditions and the climate. Historically, we do that, and it is all very sustainable because the people naturally understand their climate. They use the local materials to build their buildings. Today, we buy materials from all over the world, and we are still talking about carbon. You know, the amount of carbon you use to bring in your materials from wherever is more than offset many of the savings that we are talking about. So I think we got to go back to the kind of local, regional, climatic responsive approach and the economics of the local condition, so that people can afford to have good, stable, affordable buildings. Thank you.
明白，感谢。
Okay, got it. Thank you, Professor Lin. Any question from the floor? Well, one gentleman here. I have one question. For low carbon building, can the country propose a standard? Well, if we use the market economy to push the low carbon building, then there may be an affordable housing, and the constructor says that I only have such a budget from the government. I can only build a certain number of affordable housing. They are not willing to build low carbon housing because it would cost more money. And they are not willing to do that. In Changsha, they have a legal requirement for the buildings. It must have a circular or recycled water system. If you do not have a recycled water system, the fines would be 100,000. This regulation starts to take into effect a few years ago, but actually it's not being implemented on the ground. So whether we should rely on market economy, or should we rely on the voluntary actions of different parties? So when we develop low carbon building, it must be like classified garbage sorting. You should not just rely on the market economy, you should also rely on some administrative or government measures. If we only rely on market economy, then it's very hard to achieve 2030 or 2060 carbon targets. Well, I think Mr. Chen has something to say for this question because he's from a local company in Hunan. Mr. Chen, can you please answer this gentleman's question? Well, when I was making my introductory remarks, I said that industry policy must be supported by rigorous measures. Lip service is not enough. The implementation of the policy requires balance of interests of different parties. Ultimately, it's all about interests of different parties. Without incentives, it's very hard. Well, we have tens of thousands of participants following the event online. And the topic is really a very popular topic. Well, I'm not to say negative things about those policies. I think that people mention those policies too often. And every 3 or 5 years, they would change the terms for the policies. But the implementation is not good enough. For the government bodies, they come up with new policies every few years. Then what about the past policies? Should we continue that or not? This is a dilemma for the government. So for the industry policies, it must be very cautious and focused. Well, if the policies are too many and you are not able to implement the policies, then people would not take those policies seriously. So we have to take actions to implement those policies on the ground. So currently, the implementation of policies is one of the pain points. So carbon neutrality and carbon peaking is not just an internal request. It's also pushed by the external factors. And this is something we cannot avoid. And the top leaders have made commitments to the world. So this is not just an industry-wide policy. It has become a common task for all the society. And for the government, apart from technologies, they also need to have rigorous means and approach. For example, compulsory standards or policies, I think they would be rolled out in the future. Madame Deng, so I will add a few more points. So our research institute is focusing on R&D, and 80% of the standards are made by us, actually, for the building code. And we focus on the national policies, but how to implement the policies. Actually, the speaker from BSI talked about that. It's all relied on standards. Last week, the country has put in place a series of national standards, and we have several compulsory standards related to building. So compulsory standards mean that every sentence, every word in the standard must be obeyed.
Two of them are related to low carbon. One is built environment, technology protocols in terms of lighting or insulation or the indoor environment. Those standards are a bit different from the existing standards that are being enforced in China now. Actually a little bit higher, to be exact. Those are quite beneficial for the low carbon building sector. And the second standards would be the energy application in the buildings. We pay attention to one of the specifications, which is all the buildings needs to be installed with the solar energy system. It has not been specified whether it's PV or it's a CSP, but it only says that all the buildings must be installed with a solar energy system. This is what it said. I think that is actually compulsory, and it's mandatory, and it has to be implemented. If you can achieve those targets, if you become compliant with those standards, the cost would definitely go up, but it's not a recommendation. It has become mandatory. So it's an expenditure that you have to include in your budget. And also, when it comes to cooling and heating, the energy efficiency ratio, there is also a standard on that. So I think those standards are actually beneficial in the long run for the low carbon buildings. Actually, 4 years ago, Beijing was pushing forward with the low energy consumption building campaign. It says that for every building built, there will be a subsidy of about 1,000 yuan per square meter. If you put in place in the first year, if you put in place in the second year, that subsidy will be reduced to 800 per square meter, and then it will be even lower if you implement in the third year. So it actually encourages the developers to comply with the standards or do what the recommendation says as early as possible. If you don't do it, you have no subsidy at all. So probably, I think the local governments can formulate standards or policies like that. When we were trying to promote the green buildings a few years ago, we were saying that you will get a reward for building the green architecture. So that policy has been exercised for 3 to 5 years. And then the recommendation has become a mandatory measure. All the buildings to be built from then on needs to be green, needs to comply with all the green standards. So I think that's why we need to pay attention to all those new standards being formulated. And would you please be brief? Actually, I think Article 71 says if you don't use it, then there will be a punishment. And then I actually complain that these has been exercised and enforced too early. The punishment should not occur at this stage. And then they replied saying that it is true. So I actually doubt if all those regulations and standards have been properly implemented. And I think The NDRC in Changsha said that the NDRC is forcing those policies upon us, but there is no budget given to the local government. So it's actually impossible to enforce those policies at the local level. Okay, thank you. In the interest of time, we will have the last question. Okay, yes. I believe that is a question related to every household and everybody. So, one last question from online or offline? Okay, there. Would you please introduce yourself a little bit? Good afternoon. I'm responsible for the regional market development, also from a company or from the broad group. My question is for Mr. Deng. I think this ultra-low energy consumption standard has been enforced for 2 to 3 years, and also there are a lot of obstacles. And I think now you're responsible for low carbon in the rural areas. Actually, the rural areas are quite different from the urban areas. The people may not be that open-minded as the people in the cities, and also their economy is not quite well developed as the city areas. So how can you actually enforce the low carbon policies in the rural areas? Well, yes, that is a critical point. We do have a specialized office for the rural areas, which was initiated in July in the Qinghai province. Why we established this office in the first place? Now, globally, people were talking about carbon peaking and carbon neutrality. In China, the Ministry of Agriculture and Rural Affairs also needs to reduce carbon emission in the rural areas in China. But I think these should be a concerted effort. And the Ministry of Agriculture and Rural Affairs does not have the authority or the expertise for buildings. So like Mr. Chen said, so let's just start off and do something and take actions and then learn our lessons from trial and error. In 2017, these some of the villages in China are actually moving from coal to gas or from coal to electricity. These retrofits have been going on actually in China, in urban areas in China for several years. But in 2017 and 2018, we see that there are a lot of things to be done. You need to remove and change the windows. You need to change the wall for better insulation. And the people there, of course, were not very cooperative. And actually, in the Chinese villages, a lot of villages have become empty, and no residents, or not too many residents, were actually living there. So I think in order to achieve low carbon in rural areas, we actually would not require very, very high standards for the envelope or very thick insulation layers. We'll probably do some work and then try to introduce renewable energy. And for example, there is one project in a Chinese village that we did, that we can actually apply insulation to the doors and windows of their household, and also can use PV to drive the heat pumps to provide heating in winter. And also some subsidies can be provided, and that is how we offset the energy consumption of the buildings in the rural areas. And in the rural areas, there are a lot of wastelands, And you can grow trees there, or you can actually install some solar panels there to offset the energy consumption. So we've do some pilot projects for zero carbon villages using the funding mostly from the government. And the local people would only pay a fraction. And those pilot projects have been quite well received among the local people because those people are living in a more comfortable environment. And also the power generated can also bring those people benefits. So today I'm happy to have a discussion with some of the players in the financial sector about green funds and green investment. And a lot of investors are happy to invest in this sector. And now the payback period has been shortened from 8 to 6 years. And I think that model would be quite feasible. So let's just take action first, learn from trial and error, and then let's see if we can leverage the power of finance to make the projects more widespread. Thank you. Now we still have a lot of questions waiting, but the time is so limited, so let's just move on to the last stage. All the panelists, please sum up your idea, your observation in very simple terms. So let's start with the two panelists online. Paula, would you please go first?
Yes, thank you. Very lively discussion. There was a lot of things to learn here. That's fascinating. So thank you very much again for this opportunity. There's really only one point that I would like to share with everyone, which is the journey to reach carbon neutrality for all of us. And I think there's a slide that I would like to share for you to see. What does it mean to reach carbon neutrality? And there are actually a few steps that allow any company and organization or any project to be able to demonstrate this point. And the first step is always about measuring the current baseline and the situation. And so how many carbon emissions are emitted like right now? And for this, there are a set of standards that can be used internationally to measure that. Then the second step is about reducing and managing those carbon emissions, because this is really the main objective that we want to achieve. It's really to reduce those carbon emissions to reach carbon neutrality. But we know that right now it's very difficult to reach this step. And we will very easily always find residual emissions within all the activities. So this is why it's important to then offset any remaining emissions that are not able to being reduced. And finally, how can we demonstrate all this journey? There is a standard called PAS 2060 for carbon neutrality. And this is a standard that can be used by anybody as long as you're certified to demonstrate this achievement. And this can be used for organizations, it can be used for products, for buildings, for anything. And this was like the key message I would like to share with everyone. How to use best practice from around the world into your own projects by using standards. Thank you very much.
好，谢谢。有请。
Thank you so much. Now, Professor Lam.
Thank you very much again for this opportunity to participate. I just want to make 2 points. Much has been said about building codes and standards, and they are necessary. However, I like to say that those are baseline, basic requirements. The problem with the world today is changing so fast. Our codes and standards take years to do, and they are based on historical record and historical data and research most of the time. And when you do research today, by the time it becomes a standard and a code is 5 years. I seriously don't think we have so many years to wait, because the climate change and pandemics are going to continue to be real challenge and real threat to the existence of the human beings. We need to constantly push ahead and do it, because it is really a matter of survival. And when we do this, remember that what we know today may not be applicable tomorrow. I'm very impressed with Broad's idea of a 1,000-year-old apartment. COVID showed us in the last 2 years, our apartment had become an office, and our office had become an apartment, and the community center had become a hospital. So what will happen to those buildings that we built, often thought of as a single use and not flexible? I think that's something that is going to be really important for us to move forward, to build things that are adaptable, flexible, and resilient, and ready to be changed at minimal disruption and minimal cost. Then you will not impact the carbon, because otherwise the carbon will continue to go up. Thank you very much.
好，谢谢。
Thank you very much. So the concluding remarks from our 2 offline panelists, starting from Madame Deng. Just one sentence. For the general public, what are they seeking for? They are seeking for security, economy, and green, health, sustainable lifestyle. And for our low-carbon buildings, they can provide us with a good environment to achieve that. We hope that in the future, you all can have this kind of house and can have this kind of lifestyle. Thank you. Lastly, Mr. Chen. The dual carbon targets rely on government push and the proactive efforts of the companies, and also the contribution from all the individuals, including consumers. And they need to support and understand this target. No one should be left out. So let's give a warm round of applause to thank the 4 panelists. This is a very good format for the forum. We have discussed a lot of issues, and you can communicate with the experts and the panelists. The Hunan government and the ADB have been very forward-looking. 5 years ago, they've signed strategic cooperation agreement, and the Hunan Department of Ecology and Environmental Protection has been promoting the Asia-Pacific Forum on Green and Low-Carbon Development every year. The forum like this is to encourage more people to understand low carbon, so more companies would be working like Broad Group or Hunan Construction Energy Group or the China Academy of Building Research, so that there can be more low-carbon communities, lifestyle, and buildings, so more and more general public can understand low-carbon development more. We hope that this kind of forum can be conducted every year so as to push for low-carbon lifestyle and low-carbon policy making. This is the end of the forum. So can we have a group photo together? Thank you. This is the end of the forum.
"请各位观众朋友们把那个同声传译耳机留在会场，谢谢。
谢谢，再见。
谢谢 ，Thank you.
Thank you, Professor Lam. Thank you, Paulo.
Welcome, Alan.
Thanks, Alan.
See you. Hope to see you, Paulo, sometime.